Hi, my name is Scott Rosenberg, practice leader for cloud and automation at TerraSky, partner of VMware's, based in Israel. And I spend most of my time recently working on the Tanzu portfolio. And what we're going to talk about today is how we can actually add some custom logic to TKG, specifically TKGm. And as well as Tanzu Community Edition, and how we can actually add some custom logic to these platforms to really adopt them to our environments, which is something that I've been working on for a bit of time here. But just before we start into that, just a bit of an overview on TKGm, just very quickly. Tanzu Kubernetes Grid Multi-Cloud allows us to provision upstream clusters, Kubernetes conforming clusters on vSphere, VMC, AWS, and Azure. If you're using the Community Edition, also on Docker. TKGm is based on upstream Cluster-API, who we can congratulate today for graduating to V1 about a half hour ago. And TKGm-based clusters can be created, typically that will be done through the Tanzu CLI, but it can also be done directly through kubectl or from TMC using the user interface. Now, TKGm, when it comes to what it offers us beyond just standard Kubernetes, splits into two parts. So TKGm includes what they call basic add-ons. So this will be things that without them, our cluster isn't really going to work. Like our cloud provider interface, the container storage interface, the container networking interface, as well as some other basic capabilities like metric servers, so we can see metrics on our pods and nodes, cluster autoscaler, so we can actually autoscale our cluster in and out based off of demand from our workloads, authentication using two tools, Pinniped and Dex. To allow us to have like LDAP authentication to our clusters, and AKO, the Avi Kubernetes Orchestrator, which is the integration with NSX Advanced Load Balancer to give a service type load balancer within the cluster and to publish our services externally. But TKGm also supports additional extensions. These are installed manually, and these include Harbor, Prometheus, Grafana, FluentBit, Contour, and external DNS today. And all of these extensions are installed manually. It was drastically changed how it was done in 1.4, but in the end, it's creating values files and applying them in a specific order, and you can pick and choose which of these you would like to install. Now, one thing before we get into actually how we do these customizations, what the real use cases are, the one other thing I want to just create a baseline on is the Carvel toolset. And the Carvel toolset is used very strongly throughout the entire system. And one of the main tools that we'll be dealing with today in this session is YTT. So YTT is a YAML templating tool. It's a CLI tool that allows us basically to template out our manifests. And it's actually really, really awesome. There's two tools that are typically used in the community, Helm and Customize. Each one has its benefits, and YTT takes the benefits of both, brings them together, and adds even more capabilities in a simple and easy to use tool. So YTT is used within TKG across the board. We'll see that in a moment. Another key part is KAPP controller, which is a continuous delivery and package management experience within Kubernetes. And this is actually the tool that all of our extensions in TKG are going to be managed by. So as mentioned, YTT, KAPP controller, and there's another tool called Vendir, which helps us vendor in files from different sources into a structured file system. So all of those are used in the backend for deploying TKG clusters. And YTT is going to be the key mechanism for customizing TKGm and what we'll go through today. Image package is another tool from this, which is used in some use cases, especially in air-gapped environments. Now, let's talk about what types of use cases we have for customization of TKGm. Number one is, TKGm comes with two CNIs that we can install, Andrea or Calico. But sometimes when we have different requirements from customers, which may be to install Cilium as a CNI, or to install NSX container plugin, the NCP as a CNI, or just a customized version of one of the CNIs that isn't supported in TKG. Well, TKGm gives me the ability to set that to none in my cluster definition, and then I can manually install a CNI. But one of the great capabilities of customizing TKGm is we can actually automate this as well. With very few lines of YAML, we can actually automate the installation of that CNI for us, so we get the same experience as if it was Andrea or Calico. The ability to configure Kubeapi flags if needed. This became very prevalent in TKG 1.3.1 when the version of Valero that was delivered with TKGm could not back up persistent volumes on Kubernetes 1.20 when running on vSphere, unless a specific flag was set on the API server, which it wasn't in TKGm. So we actually have that capability to go and play with the manifests and actually add that API flag for us. And everything I mentioned here are fully supported by VMware, so there's nothing here that's breaking support of TKGm as well. Another thing is when we have large clusters, Cluster-API and TKGm, as part of that, every cluster, when you do an upgrade, upgrades one node at a time. And that's fine for small clusters, but when we get to large clusters, I've had customers with over 200 worker nodes in a specific cluster. And when you try to upgrade those in a sequential manner, one by one, it's not the best experience. So one of the things we can do with this customization is actually say how many worker nodes we would like to be upgraded at a time, which is a great capability. Also, a mechanism to automate the installation of customer apps. Things like I want to install Aqua Security or different security tools within my environment automatically, to install Caverno for policy management, or whatever it would be that we would like to automate. Also, the idea of heterogeneous clusters. This was just added in 1.4, the ability to create worker nodes of different sizes in TKGm is a day 2 operation, but this didn't exist in 1.3, and we were able to add this. And also, we can do it as a day 1 as part of the deployment in 1.4 with some customization without needing to add that as a day 2 action. And enhancing the out-of-the-box TKG extensions, which we'll be showing. So cluster resource set and YTT together are amazing. Now, what is a cluster resource set? It's a key customization point from Cluster-API itself, actually. This isn't unique to TKGm. This exists in Cluster-API. And it's basically a feature that allows us to automatically apply a set of resources onto our workload clusters automatically for us. And the way that it works is that you define your YAML manifests in a config mapper secret in the management cluster. And then in this specific resource called a cluster resource set, you target clusters by labels. And whenever a cluster comes up that has those labels, this cluster resource set will be the manifests that are embedded within it from the config maps or secrets will automatically be deployed. This is used typically in Cluster-API for CNI and CSI installations, but we actually have the capabilities of using it for many other things, as we'll see in just a moment. So TKGm uses YTT as a way to template this stuff, is to template all of our cluster manifests. And what's important to note is that all values used in the cluster configuration file that we create are data values. They're values for YTT to be used. So by adding some custom values to there, things that don't necessarily exist out of the box, we can actually customize those cluster resource sets and can really make things customizable. By integrating these two technologies, one of the great things is we can give the exact same experience to our end users for installing a custom app as they have for setting the number of CPU on a worker node. So a small example here is that all we would do, this is just some YTT templating, but what we're doing is we're just defining a Kubernetes job that's going to install kubeapps for us in this case using Helm. And we're just doing a Helm repo add and then a Helm install. And one of the things we are doing though is we're setting the ingress host name to the data values kubeapps host name. And once we've defined this YAML file like we would for a typical job in Kubernetes, we'll create a cluster resource set and we're going to target the cluster that's being created. So this is going to be created as part of our manifest for the cluster automatically. And then all we're doing here is we're saying, I'd like this.
No, no te confundas. No se cambió nada.
So we're saying that we can do this if the data values equals to enable kubeapps. Then we would like to create this cluster resource set and the config map with our kubeapps deployment embedded within it. And all the end user in the end needs to do though is set two variables in his cluster configuration: enable kubeapps true, kubeapps host name, and he's got kubeapps installed for him like everything else. Now the file layouts are, and this will change between 1.3.1 and 1.4, but it'll be either in .tanzu TKG providers YTT or .config tanzu TKG providers YTT in 1.4. But we can add any custom files we would like in here that define those cluster resource sets for us, and then they will automatically be applied to our clusters. Now, the one last thing is that Carvel package management, and then I'm going to get into a live demo, is that the Carvel package management is a new functionality added into KAPP controller. And this is actually what's used in TKGm 1.4 and in Tanzu Community Edition in order to install the extensions. So the goal of package management is to bring a similar to like Yum and apt or Homebrew, similar to a Unix style package management tool into Kubernetes itself. TKGm comes with two package repositories pre-configured. So the core add-ons, as we mentioned, and the extensions. And then we can go and install these packages using the Tanzu CLI. So building a custom repository is very easy. And a package can be based off of YTT, Helm charts, raw YAML, or a mixture of all of them. Meaning that it's a really great mechanism to wrap up any technology that we have in the back end and give a single user experience to our end users. So let's go into a quick demo here. And one of the things that we'll do, screen here, is I've actually in advance just created a few clusters just to save us the time, because deploying clusters in TKGm can take a few moments. But I want to show three different ways of how to actually customize these clusters that we have. So if we look here, and I'm going to be on CLS 01 right now, if I do a kubectl get nodes, one of the things that we can see is that I've got 3 control planes and I've got 3 worker nodes here. And if I do a kubectl get namespaces, we'll see this is what comes out of the box with TKG. There is nothing custom installed here. Everything is typically as expected within a cluster that comes straight out of the box from TKG. Now, one thing that I did add here is a package. And this package is, I called it TKG extensions. Now, we can see here all the packages that come out of the box from VMware. But one of the annoying things is that you still need to install them manually. And they actually have a lot of customization capabilities. And what happens if we want to give a better user experience of maybe having an opinionated method of how to install the extensions, but do it through one single command? So that's what I've done here. I've actually wrapped up all of these extensions into a custom one called TKG extensions by just building a simple package. And the way that we can install this is actually really nice. We can just use the Tanzu CLI. And if I just go here into my package folder. What we can see is that all I'm going to run is a Tanzu package install, and I'm going to tell it which package I would like to install and which version of it, and just give it a values file. Once I run that command, this is going to run for just a few seconds here, and my job is done. I will have, within about 2 or 3 minutes, I'll have Grafana, Prometheus, external DNS, Contour, and FluentBit all configured in my cluster as I've decided. And all the user needed to do in order to create this was create this simple values file. What domain they're using for external DNS, their cluster name and management cluster name for FluentBit, DNS server, syslog, the Grafana FQDN they would like, some LDAP settings for Grafana, because one of the things is that the out-of-the-box Grafana does not have LDAP authentication. So using a custom package, I can adopt this and actually add capabilities above what exists out of the box with their packages. And if I do a kubectl get namespaces right now, we can already see that I'm starting to get the Tanzu system monitoring and Tanzu system service discovery are coming up. We see that cert manager has been installed, and slowly this is going and installing all of our packages for us in the back end automatically. And to delete all of our extensions, we just delete that one package as well, and it will delete everything within it. Now, excuse me, another thing that we talked about during the example before was the idea of having multiple types of worker nodes. And if we look here at this cluster, and I do a kubectl get nodes, one of the things that we can see here is that I actually have a machine deployment 0, machine deployment 1, 2, and 3. So I actually have 4 different types of worker nodes. And the way that this was actually done is just through a very simple, through actually at deployment time. So if we look here at my clusters and I look at how the actual cluster manifest looks, if we look here, everything is the standard way that we would usually set something up. But then I've just added some custom values. Said, hey, I need an additional machine deployment count of 3. And these are the values that I want you to give it. I want you to set autoscaler. I want you to set CPU, disk gigabyte memory, all different for each of my VMs. And that's in the end how the end user experiences it, the exact same way that he would anything else. But in the back end, what we've actually done is just use a bit of YTT. What we've done is actually just created 2 simple files here. And this is the main one, which is a YTT file that all we're doing is actually overlaying values. We're running a for loop here for every time, for every number within that additional machine deployment count. And we're just stamping out machine deployment YAMLs and machine templates and kubeconfig templates and everything that we need in order to deploy a cluster, we can get automatically out of the box here. So it's a really good experience for our end users. Now, the one other thing that we have is, what if I gave that same experience for installing, let's say, the entire Tanzu suite? So I did that. And we can actually see that here with our code connect. We can actually see that I have this small little script here of install Tanzu software. And if we look at what the install Tanzu software command can give us, it actually has the ability to install cert manager, Contour, external DNS, Prometheus, Grafana, and FluentBit. But we can also install Tanzu build service or Tanzu Postgres, Tanzu RabbitMQ, Tanzu MySQL, or Valero, all out of the box. Now, I've created this as a script that you can run locally on your machine, but also I've added here a flag for in-cluster. And the way that this works is actually really simple. Just like we created the custom files before for managing things like the machine deployment count, we can do the exact same thing for running this script in a job in Kubernetes. So if we go here to TKG providers Or, and I look here, we can see that I have these two files, install Tanzu software and install Tanzu software default values. And if I look at our default values, one of the things that we can see is that I've set up a bunch of data values that the user can configure. Things like, okay, what would I like installed? Would I like to install Cert Manager or Contour or external DNS? All of the different values that are relevant for those specific softwares. Same thing goes for install Tanzu build service, yes or no, and the bundle for Tanzu build service and the registry, all the different values that we need in order to deploy these different pieces of software. And then if we actually look at the file itself of how this gets installed, all we're doing is creating a job from a container that actually has this script in it. And all it's doing is running install Tanzu software with basically parameterizing and pulling in all of our data values. And by doing it this way, what we've been able to actually do is write this file once. And now anytime my user wants to go and create a cluster, what they can do is use a file similar to this of CLS02. Use just a redacted one because I don't feel like showing my TanzuNet password, people. But we start with our regular configuration, and then we say enable Tanzu software auto installation, yes, and just say what we would like installed. And so this can be saved in Git. This can be saved however you save your cluster configurations today. You can do the exact same thing on your end and actually just have this automatically install whatever software we need. This can be Tanzu build service. It can be things like FluentBit and other plugins, or Tanzu RabbitMQ and Tanzu Postgres. So if I were to go here, actually move over to one of those clusters, this one, and I came here and did a kubectl get, and we can see I all of a sudden have get MySQL because I actually have the MySQL operator installed for me automatically here. And same thing goes for Postgres, because that's what I decided in that cluster. I've also automatically installed Valero and RabbitMQ because those are the systems that I decided that I wanted as an end user to deploy automatically. None of that was manually installed. So this gives the best developer experience for deploying clusters. And I would love at this point, before I continue, if there are any questions, please let me know. There is, by the way, okay, I'm seeing here in the chat. So I do have a Git repository that I can actually show you guys here. And I put at the end of the slide deck also a list of a bunch of different helpful resources that can be used here. But if you just go to GitHub, is vrabbi is my handle here. And if you go here, what you can see is that we actually have a branch for TKG 1.4 and 1.3.1. And if we go into here, what we can actually see is how to build the Docker image itself that would be used for the automated installation of everything. There is a disclaimer here that you can't run it as is, and it tells you what you need to download from my VMware, just because I can't publish the commercial binaries of VMware here. But we do have all of the installation scripts that you can use. And then there's also all of the TKG customizations. So for example, in the custom YTT overlays, we can see for like cluster configuration changes, there was a question in the upstream Cluster-API community about adding a maximum pod configuration of how many pods can run on a node. So all I did was set a simple YAML file here, which there's a pods per core and maximum pods values that exist within Kubernetes. And all we're doing is setting those, and we set default values. And now once I've set this file, any user, if you put these into your .tanzu folder, will actually be able to just say control plane max pods per core or worker max pod per core in their file and set maximum pods per core. Same thing goes for trusting custom CAs or adding custom NTP if you're DHCP server doesn't send out NPP to the servers. Multi-machine deployment, what we talked about of having that heterogeneous cluster. For installations, you can see here, I've also set them up instead of just a one fits all, Tanzu install the entire software. I've created ones here for each and every software, including things like attaching to VROps, attaching to Tanzu observability and Tanzu mission control automatically. All of these things can be done through here. And what you can also see is, for example, extension modifications. So Harbor in TKGm does not come with Chart Museum installed due to some issues that exist in Chart Museum. But if you would like to use Chart Museum like exists in the open source Harbor, you can use this small addition here, which talks about how to just update the value. You just put this file into the folder as explained, and then it will automatically install Chart Museum for you in Harbor as well. Same thing goes for Grafana. I think I mentioned it before, but Grafana does not support LDAP authentication in the TKGm packaging. So if we want to do that, we actually can really easily. All we do is create these files in the relevant folder. You just need to update your LDAP TOML to be with the actual correct values for your environment and not example.com. And at that point, it'll work for you out of the box. So this is just, again, an example of the types of things that we can do with TKG extensions. And another thing that I've just started to play with is the packaging, because that's new in 1.4. But if you would like, you can look here at the Carvel packages. And I built one for deploying Octant as a service within Kubernetes behind an ingress controller, or running Open VS Code as a pod within TKG, that then you can just connect from a web browser and have VS Code in the browser for yourself. Or the TKG extension bundle that was mentioned, that's all here as well, with examples of how you actually go about building this. So all of this stuff is here and documented. If there are any issues that people have, please let me know. Also, there are different helper scripts that I've put together. And the one other thing that I would suggest people to look at is yesterday, the winning team from the hackathon, actually it was the Tanzu for 1M, I think, which was the team I was on for the hackathon. And we actually built a Terraform provided for Tanzu mission control and a bunch of modules that help us install extensions also, for example, all using Terraform onto TKG clusters. So if you would like, you can also take a look at this. And so definitely take a look at what exists here, and let me know if there's anything you would like to add there as well, or anything of that sort. So around, I see one question here on more details on batch upgrading of worker nodes. So basically the way that that works is within Cluster-API, if I did a kubectx to I just went into my management cluster to my machine deployment. Let's say, I did that on code 0.1. If I went and edited this machine deployment, one of the things that actually exists here within Cluster-API is under the rollout strategy, we have a max surge and max unavailable. So you can just change these values and that can be set as well automatically. Cilium is not in my repo. That is correct. That was done at a customer that I don't have the code that we built there out right now. But if that interests people, I can rewrite that and put that up there as well. But so rolling updates, that's how you would configure it as well. And yes, Spiffy and Spire can be installed using the same approach. Not an issue at all. Tanzu packages cannot be used on vSphere 7 or TKGS currently, but you can install the packages of 1.3.1. It has to do with the version of KAPP controller in TKGS. That will, it may have changed in update 3, which was released, I think, yesterday or the day before. I haven't had a chance to look at that yet, at what version comes in that version of TKGS. So I hope that this was helpful. And just to summarize here quickly, There is a list here of useful resources. The cluster add-on bootstrapping blog post from Yammir's is awesome. There's a great Katacoda tutorial for using KAPP controller package management, which I suggest everyone to do. My TKGm customization folder or GitHub repo, and the Tanzu Solution Engineering TKG Lab one is great as well. And the playground for YTT on carvel.dev, all really helpful. I hope that this was helpful. And thank you guys. And yeah, YAML is definitely, I do not believe there's such thing as DevOps or IT today. We're all just YAML engineers. So yeah, I've been having a lot of fun with YAML. And all you guys should get used to YTT because it's one of the best tools. And would love to see, you know, anything from the community. If people have questions, anything, just let me know. You can reach me on VMware Slack, Kubernetes Slack, Twitter, LinkedIn, whatever. More than happy to always converse and talk about how we can move forwards TKGm into a more customizable type of platform. So thank you guys. And yes, I will upload the presentation with the links. I see that in the chat of GitHub was released. I will update this. I will upload this in a few minutes to the TKGm customization GitHub repo so that you guys can have a copy of the presentation from there. So thank you all.